So this video is going to be how to find limits at infinity, or how to evaluate a limit where infinity is going to be one of the answers. So this is just remembering things when you're working with infinity, which can be a little bit difficult since infinity is more of a concept rather than an actual number. So before we get started looking at a couple specific instances, I just want to remind you guys of a couple things about how infinity works. So first, we're going to write, this is something that we're going to remember as we work on these problems. And one is, if you have some number like 5 or 3 or -2 or anything, if you have some number over infinity, anytime you have a small answer divided by infinity, we're going to say that's essentially 0. It's not exactly 0, but it's basically 0. The other situation is if we have a number divided by 0, then that's going to essentially be infinity. So the idea here with the first one is you're saying you're taking something really tiny and dividing it by something huge. That's basically 0. The other one is if you take a number and you divide it by something super tiny, it's going to become something huge. You can actually check that on your calculator. If you took 5 and divided it by like 0.000001, you'd actually get a huge number. So those are the two things that we're going to remember. They're going to help us as we're working on the problems for today, just to know which answer we can have. So the first type of problem that we're going to look at is where we're looking at end behavior asymptotes, which would be slant asymptotes or horizontal asymptotes. So that is what we are looking at first. And sometimes people call slant asymptotes oblique asymptotes, and you can write it whichever way you want. So when you're looking at these, actually there's a trick on this. I think if I hold it down, it straightens it. Isn't that cool? Anyway, all right. Sorry. So we're going to do a few examples of this one. The thing that you should be thinking about as you do these problems, specifically we're going to be finding limits as x goes to negative infinity and x goes to positive infinity. In your brain, what you're thinking is which one wins. That's what you should be thinking. So here is our first example. We are going to say that we are given a function where we have 3x squared plus 1 divided by 5x to the third plus 2x. And with that function, we are going to find the limit as x approaches negative infinity of the function, and the limit as x approaches positive infinity of the function. Alright, so first we'll go ahead and do the negative infinity version. So I'm going to say the limit as x approaches, that was terrible, as x approaches negative infinity of 3x squared plus 1 divided by 5x to the third plus 2x. And when we look at this, we just have to think about, like I said, which one wins. So if you look at this, if you're taking 3x squared plus 1 and you're plugging an infinity in for that x, that plus 1 is not going to do a whole lot when you're doing 3 times infinity squared. So we're going to ignore that one. On the bottom, if you have an x to the third and an x, the x to the third is definitely going to win in that case. X to the third is going to be much bigger when you repeatedly work with infinity with that. So these two are kind of ignored. So basically when you're looking at this, you're just going to look at your highest exponents here. And if you can see, the top has an exponent of 2, the bottom has an exponent of 3, so that means that the bottom wins. So this is a situation where we're going to have an infinity on the top, but we're going to have an infinity on the bottom that is much, much, much larger, if that makes sense. So this is a case where we have like a number over infinity, or a smaller over infinity over a larger infinity, and so this is going to be 0. And then we'll go ahead and do the limit as x approaches positive infinity. And again, for the same reasoning, this one's going to be 0. In this case, it doesn't really matter if it's positive infinity or negative infinity. Either way, it's just going to be 0. Okay, and I'm going to go ahead and show you guys a picture of that so that you guys can see. Here's this one. No. There we go. Sorry, new to this. I'm gonna move it over here. So if you want to draw a little sketch of that, you can. You can see that as x is approaching negative infinity over here, you can see that it's approaching the x-axis, which is 0. As x goes to positive infinity over here, it's approaching the x-axis again, which is 0. And so you can see from the picture of the graph that it really makes sense that those are your two limits. So anytime you're doing a problem like this, looking at graphing it and looking at the graph is a great way to check your work if it's a calculator active problem, which of course it won't always be. So, all right, next example. We're going to say we are given the function 3x squared plus 1, you can tell I was being lazy, over x plus 5. And again, we are going to find the limit as x approaches negative infinity of f of x, and the limit as x approaches positive infinity of f of x. Alright, so we'll go ahead and do the negative version first. So I'm going to say the limit as x approaches negative infinity of 3x squared plus 1 over x plus 5, and again we're looking at which ones win, so I'm looking right here, and here I have the top is going to win for sure, right? You can see that we have 3 times negative infinity squared divided by negative infinity, so I know that numerically my answer is definitely going to be infinity, because that's infinity divided by something smaller. However, whenever we have infinity as an answer, we want to know if it's a positive or a negative infinity. So I have to consider what's happening to the top when I plug that negative infinity in, what's happening to the bottom when I plug it in. So on the top, we have a 3 times a negative infinity squared, which is going to get rid of that negative, so that's going to give us a positive. And then on the bottom, we have just a negative infinity. So we are doing a positive divided by a negative, and that means that our answer here is going to be negative infinity. And then of course we're going to say that technically that means that this does not exist, and the reason for that is unbound. Alright, and then we'll go ahead and we'll do the positive version. The limit as x approaches positive infinity of 3x squared plus 1 over x plus 5, and again, I guess I could have boxed that. Easier to see. Okay, so again, we're going to do the same thing. We're looking at the one that wins, and we know that it's going to be infinity, and we just have to figure out what sign that infinity should have. So on the top, 3 times infinity squared is going to be positive. On the bottom, we have a positive infinity, and since we have a positive divided by a positive, that gives us a positive infinity. So again, let's go ahead and just look at the picture of this and make sure that it makes sense. And that was this one. Alright, so if you look at this picture, you can see that as x goes to negative infinity, well actually first you can see that it's got a slant asymptote right here. So as you follow x to negative infinity, you can see you're looking over here on the graph that's negative infinity. As x goes to positive infinity, you can see it's up here on the graph. So, and then make sure right here that we also say, even though it was positive infinity, technically that does not exist, and that's because it's unbound. Alright, next we're going to go ahead and do another example. So this time, I'm going to start to shorthand these a little bit. The instructions are all the same. The function that we're going to look at this time is x squared minus 1 over 2x squared minus x minus 3. And again, we're going to find the limit as x goes to negative infinity and the limit as x goes to positive infinity. So here, the limit as x goes to negative infinity we're going to be looking at the one that wins, right? So we're looking at the highest exponent. And if you guys can see, they're exactly the same size. X squared and x squared, neither one of those is going to win because they're the same, so we can think of those as canceling out. So once they cancel out, we just have to look at what they leave behind. The x squared on the top leaves behind a 1. The 2x squared on the bottom leaves behind a 2. Alright, for the next one, we're going to do the limit as x goes to positive infinity of x squared minus 1 over 2x squared minus x minus 3. Again, by the exact same reasoning, we're going to get 1/2. In this case, the positive infinity versus the negative infinity did not matter because you have an x squared. If you'd had an x to the third, it would have made a difference because you wouldn't have had the squared forcing it to be positive. So be careful on these. It is possible for you to have different signs depending on the exponent that you're working with. But since this was x squared, I knew that they were going to be positive over positive, and so it wasn't going to matter. Alright, and then last example for these type of asymptotes, we're going to look at f of x is the square root of 2x squared plus 1 over 3x minus 5. So again, we're going to be looking at what wins on the top and the bottom. So I'm looking at this part. This is where things start to feel a little bit weird. So I'm just going to go ahead and write some things underneath so you guys can see it really well. I'm going to look at the top as the square root of 2 multiplied by the square root of x squared. And then on the bottom, I'm just going to leave that as 3 times x. So what you'll notice is that that square root of x squared is really just an x, right? So if we look at this, that means that, I'm going to use a different color real quick, maybe orange. So that means that this right here is just a plain old x, and what you have to think about is that negative infinity is being plugged into the square root of x squared. So that means when you plug in that negative infinity to that x on the top, it's actually going to be a positive infinity, and when you plug in that negative infinity to that x on the bottom, this one right here, that's actually going to be a negative infinity. So we have those numbers, those infinities are canceling out, although we know they're canceling out to equal a negative, but then we do have those number coefficients right here. So we're going to say that the limit here is negative, because you had a positive infinity divided by a negative infinity, negative root 2 over 3. Alright, and then we're going to do the same thing for the positive version. So there's our leading. Those are the ones that win right there. And again, we're saying that we still have that top part that's going to simplify to being root 2 times the x, and the bottom, which is going to be 3 times x. Only this time we don't have differences in the signs. We have the same signs. So when we do this one, it's going to be like the case last time, except we're going to have a positive infinity over a positive infinity. So that's going to be root 2 over 3. Alright, and I'm pretty sure I have a picture of this one. And that was this one right here. So if you look at this picture, you can see that we have as x goes to negative infinity is over here, and you can see that it actually had a little bump up right there. There's actually a little maximum, but then it levels off for that horizontal asymptote right there. So as x goes to negative infinity, it's got a negative number for that horizontal asymptote, which we know now is negative root 2 over 3. And as we look at x going to positive infinity, we can see it's going up. It's a positive value there. So we do have two horizontal. Alright, so next we're going to look at vertical asymptotes instead of horizontal asymptotes and just see how things are going to be a little bit different there. And we're going to put a definition in here about vertical asymptotes. So the definition says the line x equals a is a vertical asymptote of the curve if, and then three things can happen. If the limit as x approaches a from the left of f of x equals positive or negative infinity, if the limit as x approaches a from the right of f of x is positive or negative infinity, or if the limit as x approaches a over all of the function is positive or negative infinity. So that is basically the definition of how you know that there's a vertical asymptote at a certain point. Alright, so now we're going to do some examples. Actually, we're just going to do one, but this one example has two parts to it. Kind of a catch-all. So we're going to be given the function f of x, and f of x is x minus 1 over x to the third plus 3x squared. And as we work with this problem, we're going to be finding the limit as x approaches 0 of f of x and the limit as x approaches negative 3 of f of x. So when we look at this problem, I can see that if I was to try to take 0 and plug it in, do direct substitution, 0 would be an issue for the bottom, right? And so if I go ahead and factor f of x, then I'm going to be seeing that f of x is x minus 1 over, I can take out a GCF of x squared, and then that leaves me with x plus 3. Whew, that did not leave me much room. So I can see that this is a vertical asymptote because my factors are not canceling. That means that I'm never going to be able to plug in like 0 exactly. So this is one of those situations where when we do this problem, we're going to go ahead and we're going to do it by finding the left hand limit and the right hand limit. So I'm going to say that first I'm going to do the limit as x approaches 0 from the left of x minus 1 over x squared times x plus 3. And here, remember, this is a situation where our answer is going to be a positive infinity or a negative infinity, because that's what happens with vertical asymptotes. And so that's why it's important for us to do this left-hand limit and right-hand limit, because we have to know if the left hand is positive infinity or negative infinity, and if the right hand is positive infinity or negative infinity, and then if they agree with each other or not. So here, if we plug in a number that's basically 0 but a little bit less, so a little bit negative, then 0 minus 1 on the top is going to be negative 1. A 0 that's a little bit negative when you square it is going to be 0, but it's going to be a positive. And then a 0 that's a little bit negative plus 3 is going to essentially be 3. So what we have here is we have negative 1 divided by 0. And if you guys remember at the beginning of the notes, I said that a number divided by 0 is infinity, but we have a negative 1 being divided by 0, so that's actually a negative infinity. Right? And again, we know that that does not exist on bound. We're not going to write that yet because this is not our final answer. Next, we want to look at the limit as x goes to 0 from the right. So again, on this one, if you have a number that's 0 basically but a little bit positive, and you're subtracting 1, that's still negative 1. 0 squared is still going to be 0. 0 plus 3. So again, we have negative 1 over 0. So that means that the left-hand limit and the right-hand limit are actually both negative infinity. So those two things agree with each other. That means that we can conclude that the limit as x approaches 0 of the function is negative infinity. We can conclude that. However, now we're going to go ahead and say does not exist because it's unbound. Okay, and then we can go ahead and work on the other one. So now we're going to say the limit as x approaches negative 3 from the left So here, if you have negative 3 minus 1, that's negative 4. Negative 3 squared is 9. And then this is the part we're interested in. If you have negative 3 and positive 3, that zeroes out. But your negative 3 is a little bit more than negative 3. That's like negative 3.001. So it's going to cancel out the 3, but then a little bit more. So I'm going to call that negative 0. And the reason I'm going to do that, we have a negative 4 over a negative 0, and that tells me that this is actually approaching positive infinity. And that's because that 0, it's a number very, very close to 0, but it's a little bit on the negative side. So now I can go ahead and I can do the limit as x approaches 3 from the right side. That was negative 3. So again, I've got negative 4. Again, I've got the 9. And again, the negative 3 and the positive 3 cancel out. But this time, since it was negative 3 from the right, I wasn't really subtracting 3. I was subtracting negative 2.99999. It's something a little bit less than 3. And so what actually happens is, even though that number is really, really close to 0, it's a positive 0. And so that means that this is actually approaching positive infinity. So here our conclusion is going to be the limit as x approaches 3 of the function does not exist. And the reason it does not exist is not because it's unbound. The reason it doesn't exist is actually because there's two values there. One went to positive infinity, one went to negative infinity. So let's go ahead and get a picture of that, just so you guys believe me. That's this one right here. So, and you can see it too. If you look, you can see that here, right in here, that's where 0 is, right? And I can see that both sides of the graph are going down right there. So that limit is negative infinity. But when I look at negative 3, the left side goes up and the right side goes down. And so the limit there does not agree. All right, we are almost done. One last thing for you guys to write. This is a definition, so I'm going to write this in blue. We are going to write down what some indeterminate forms are. And indeterminate forms would be like forms that are like not mathematically defined. And so one indeterminate form is 0 divided by 0. If you have that, you should be like, oh, I don't know what that equals, because we have to do some other math to work with that. Another indeterminate form is infinity over infinity, and we actually kind of dealt with that one today. This is a special one in that we're going to deal with it in a more precise way later, a way that's a little bit more mathematically formal, and we're going to have a lot more behind our answers than just to say those infinities are the same size. So we kind of dealt with that one today, but we're kind of going to say that it's one that we don't know just yet. So put a star next to that one. That one's kind of special. The other indeterminate form is going to be 0 times infinity. Another indeterminate form is infinity minus infinity, 0 to the 0 power, 1 to the infinity, and infinity to the 0. So for all of those, if you are working on a limit and you see these forms, with the exception of this one, because we can kind of fake our way through that one, if you see these, you stop. And that's because we learn these later. Now, as you might have noticed from the notes that we did today, there's some forms that seem like they're kind of in the ballpark of those, but we can actually work with them. So one is like infinity squared, or infinity times infinity. We know that's just infinity, it just makes it bigger. We also know that like infinity plus infinity is going to be infinity. So those